like your Tesla cars, this is going to be a purely electric system. We're going to get rid of chemical reactions. We're going to get rid of the need for fuel depots out in space. We are going to use electricity as the primary source for fuel for our spacecraft.
This podcast is sponsored by Siemens Digital Industry Software. Learn more about their simulation and test solutions by clicking the links in the description. Build a better tomorrow faster with SimCenter. Welcome to a new episode of the Engineered Mind podcast. I'm your host Jousef, and on this podcast I'm talking to researchers, scientists and engineers and how their work is shaping the world around us. For this episode, I'm very delighted to welcome Alfred Belen to my show. Belen Aerospace was founded by Alfred Belen III, the son of a physician and an engineer at Boeing. Alfred was raised in California and became a doctor himself. It was during his time in the United States Air Force he first thought of the concept of internal atmospheric propulsion. He founded Belen Aerospace in 2021 with the hopes of making new discoveries in the realm of space travel. In this podcast, Alfred and I talk about how we can make jet propulsion work in space, the sail effect, material science for powering vehicles in space, how to overcome chemical propulsion systems and make them more reusable. We talk about patent laws, and last but not least, a personal pitch to Elon Musk. If you would like to support the episode, make sure you rate the podcast on the platform of your choice to make sure more inquisitive scientists around the world will listen to this show. Subscribe if you haven't already, and now, ladies and gentlemen, enjoy my podcast with Alfred Belen.
No, but I'm excited to be on your podcast, Jousef. I know I've been following your posts and whatnot, and all your technical and your formulas for all the things that you post on your website, or in your podcast and your website are always very kind of inspirational and whatnot. So I'm very interested in mechanical engineering, even though I don't have any formal training, and my project has to do with like high pressure systems and thrust production, things like that. Very interested in, I think one of my podcasts, I talked about universal gas equation, and I know that you've had a lot of videos on like fluid dynamics, which is another interest of mine because of, how it affects my prototype in regards to the concept we're trying to develop here. So, but yeah, no, I think we've talked about this in the past as well. The video about the Lego submarine was one of my favorites, mm-hmm. Where, it's things like that, like people kind of like doing, not really big scale experiments per se, but, experiments that really just kind of challenge your mind in regards to, the physical aspects of like even small machines to see how they work and whatnot. So it's always been very inspiring to me. So I'm glad that you have this podcast and whatnot.
Yeah, thank you so much. I appreciate it. And I think we can leave that in the podcast now, just kick things off. Alfred, thank you so much for being on my show. I know you also have a podcast and do some interesting stuff on the side. So maybe for the listeners, can you talk a little bit about yourself? What's your background and what is actually your project that you're working on at the moment?
Yeah. Oh, I'm happy to, Jousef. Thank you for having me on your podcast. Background-wise, my training is as a physician, so actually I'm not an engineer, but I was in the U.S. military. I was in the U.S. Air Force for 4 years, and during that time, I had this idea in regards to propulsion, and it's been kind of like a seed in my mind for 20 plus years, and I really haven't had the time to kind of explore it until now. But my concept has to do with propulsion. I call it internal atmospheric propulsion. We have a podcast called Jets in Space, and the basic premise of our concept is that in the vacuum of space, possibly underwater, but more importantly in the vacuum of space, if we could devise a high pressure system that recycles the gas that is compressed, we might be able to make electricity as the primary source of fuel, as compared to like a chemical reaction. It's not a combustion reaction. This is purely a high pressure system where the gas is moving from an area of extremely high pressure to an area of extremely low pressure, and then inside of a sealed container, the potential energy of that gas as it is moving from high to low pressure is producing thrust, but the gas isn't being extruded into the vacuum of space to be lost forever. It is actually being captured again within a container, and then hopefully reused again, compressed again, and then extruded again. And and I've been kind of dealing, is this going to be a continuous cycle, or is this going to be more like of a almost like a capacitor where there's going to be a little bit of high pressure and then you release it, and then it takes maybe minutes, hours to re to reset the system where you build up the pressure again. I haven't come to like a conclusion about that, but the basic issue is that if we could do this theoretically, electricity being the primary source of fuel, we could produce thrust in the vacuum of outer space without needing like really heavy chemical fuels, and fuel depots. So it would be a way of theoretically, if we had electricity through solar panels or electricity through like a nuclear reactor, then we could use the electricity as the primary source of the propulsion instead of you know um, chemicals, which are very difficult to store, to transport, and to find in other areas, like on other planets and whatnot. You'd have to refine them and get them into containers and whatnot. But that's the gist of my concept. And I have some people working with us. It's still a work in progress, but I'm very happy to talk with any of your podcast followers and engineers particularly. I have some people that have been talking to us, but we're as of right now we're still in the prototype phase, and we're very excited to talk to everyone pretty much about our concept, the feasibility and the prototypes and whatnot. So thank you for letting us talk about it on your podcast.
Sure. I think it would be interesting if you could probably talk after the podcast to Jim Cantrell, one of the co-founders of SpaceX. I think he's now founder of Phantom Space. So it would definitely be interesting to get in touch with him to see what he thinks about your idea. But I think regarding your idea, I think it's still at the prototype stage, right? You showed me some images on LinkedIn. So how's it going at the moment? Which
Yeah,
phase are
no,
you
thank
in?
you for asking about that. So yeah, so it's in the prototype stage. So there's several components to our prototype. So initially, I thought we could go directly to some type of uh, a compression motor within the system, but we decided to try and trying to make it even more basic than that. So in the high pressure system, we found a very small canister, a gas canister. I think that it's used for paintball guns or whatnot, and it can hold 300 psi. I don't know what the conversion is to metrics in regards to the 3,000 psi, but that is a lot of amount of pressure. It's about the size of my hand. So
Mhm.
that small canister can hold 3,000 pounds per square inch. Right now in our prototype, we're attaching an electronic valve and a nozzle to the end of that canister, and then
Mhm.
we're gonna see how much thrust we can get from releasing the 3,000 psi from that canister um, in a stream of gas to make thrust, of course. And then after we have that set up, we're gonna enclose it within a lightweight plastic container um, to see if we can produce thrust, even with the gas being in an airtight container. So that's our prototype, and we're hoping to get that up and running in the next several months.
Yeah. What kind of tests are you performing? Is also simulation involved in all the prototyping phase that you're doing? Is like, are you using CFD software tools, anything like that?
No, that'd be awesome if we could do that. We're not at that stage yet, but yeah, no, there's lots of variables that we would like to monitor. So of course, like the pressure within the system, the amount of force generated by the release of the gas, um, and eventually, once we have the the technology and the support to do it, like I know I've seen some videos on your podcast, like fluid dynamic types of things, because one of the challenges is
Mhm.
going to be as the gas is extruded out the back of the mechanism. There's going to be is there going to be laminar flow when the gas is being recycled and whatnot. So there are a lot of things that we would like to look at this point, where we are mostly focusing on thrust production and then and gas capture at this point. But a lot of designs, we even talked about the shape of the container, because that's going to affect laminar flow and whatnot. So that in my in my patent application, I just put like a basic cylinder. I didn't make any kind of specific type of shape to the container. But one of the ideas I have that I talk about on my podcast and whatnot is a heart shaped container. So a heart shaped container, if you imagine like the shape of a heart, where at the apex of the heart you would have the compression chamber, but the sides of the container are more rounded. So that would
Mhm.
theoretically allow the gas to expand to the aft or the rear of the mechanism, but as the gas is expanding rearward, it's also expanding laterally. So there could be a way that we could allow the gas to expand in both the rearward and the lateral direction. And then as the gas loses its potential energy as it reaches the end of the mechanism, then the laminar flow hopefully could be rounded out, where like I guess the rounded areas of the heart are allowing it to return back to the front of the mechanism and then being compressed again for another cycle of thrust production, pretty much.
That sounds really cool. There's also something called you. I think we mentioned earlier in the like before we actually had the podcast, something called the sail effect. Could you elaborate on what that actually
Oh
is?
yes, yes. So yeah, I talked about that because I know I think when I was corresponding with maybe one of the either engineers or someone that was following me on my podcast, they mentioned that it makes sense that as the gas is being released at the back of the mechanism, it's going to hit the either the sides or the back of the container, and that put the pressure from the air pushing on the back of the container can be like a sail effect. Like when the wind hits the sail, it's going to move the mechanism in a certain direction. So we try to minimize that as much as possible because we don't want the gas to be hitting the back of the mechanism in a perpendicular manner. We want it to be emitting at an angled manner, so the gas forces are being distributed in a way that doesn't kind of counteract the thrust production that's going out in the opposite direction, pretty much, of the mechanism. But yeah, that's another great thing, that we want to work on. The engineers that are experienced with like fluid dynamics and whatnot, we're going to try and make the flow of the gas um, as beneficial as possible in regards to maximizing thrust in one direction and minimizing, like the negative effects. I guess it's in some ways it's like almost like a form of drag, but it's more, as I call it, like sail effect. It's the gas pushing on the rear of the mechanism. We're going to try to minimize that as much as possible.
See, especially now that you mentioned this, I think it would really, really be interesting to see what CFD results you can actually produce, having the prototype and see what CFD actually predicts. For example, also for your heart-shaped prototype that you're working on. So I think after the podcast, Alfred, we can get together and I have some ideas what we can do definitely to
Yeah,
simulate
no,
all of that.
awesome. No, I'd be happy to talk with any of your listeners or any fellow engineers that you know out there that can give even help me to talk about maybe refining the prototype to make it more efficient and whatnot. I'm always happy to talk with people about that. Thank you, Jousef.
Yeah, definitely. When it comes to material science, like, do you also think a lot about what materials that you'll be using for your prototype and all of that?
Yeah, no, I appreciate you bringing that up because, yeah, one of the things I do mention is that, thrust to weight, pretty much, that's going to be in any kind of mechanism where you're trying to move an object. You want to maximize the force that's moving the object and then minimizing the weight, which it has to be moved and whatnot. So,
Mm.
yeah, we don't want it to make it like really heavy materials, but we want it to be strong enough to withstand the pressure of the system. And I know from just, kind of casual reading from like aviation text and whatnot and aviation magazines that carbon fiber, especially, I think it's the 787 is the Boeing's airliner that has used a lot of carbon fiber technology, where I know the weight of the entire airplane is reduced significantly because the carbon fiber structure is produced in one whole piece, and there's significant weight reduction but increase in strength at the same time. So we're always looking for the lightest weight materials with the greatest tensile strength to kind of resist any kind of, because we're doing gases under high pressure. We have to have a strong enough material that can withstand the forces within the compression chamber, pretty much. But yeah, so but there could be other materials. I'm sure a lot of aviation aluminum is used and whatnot. But I'm happy to talk with, again, anyone who's experienced or has any expertise in that area. Um, some of my like basic prototypes and whatnot have used just, like simple plastic containers for the airtight container, which is feasible. But at some point, we're going to need a more robust kind of prototype that has stronger materials.
I see. It's so funny that it all comes full circle because I actually know someone who's a PhD student. He's part of a startup. They're actually developing carbon fiber materials for space. So I
Oh,
think
great.
also in that aspect, I think we can get together and I'll get you in touch with him. So maybe there's some great collaboration that we can work on um, in the future. That would be really, really cool.
That's awesome. No, I'm glad that you have all the connections. So
Yeah, definitely, that's really cool. Um, I'm not sure if you mentioned it, but the thrust to weight ratio, is that something you would like to? Is that something you're working on at the moment to actually optimize this, the thrust to weight ratio? I think you briefly mentioned it before.
Yeah. So I'm always trying to consider, like what we could do in regards to weight reduction. So all the basic components, whatever we could do to minimize the weight. Um so if the mechanism is going to involve at this point, it's just the gas canister, the lightest weight gas canister we can use for that part of the system. But even the other components that may come into play in the future. So um, I think that one of my collaborators, Ashish, talks about like battery systems theoretically for
Mhm.
powering the system in the future, but anything that affects the weight. So whether it be batteries, whether it be the motors, whether it be even if we're going to use like I talk about turbofan technology just because that is one of the best ways to compress gas is like the turbofan technology. Um, Anything that reduces the weight of the turbofan of the electric motor. Um, these are all the things that we're trying to look at in regards to weight reduction. But I know there's a lot more experienced and more uh, smarter engineers out there that I sure can tell me what's available out there. But yeah, anything that will reduce the weight because we want to maximize the thrust as much as possible, but also minimize the weight so we can get a maximum kind of propulsion out of the system. Yep.
Yeah. Is it, by the way, the only part that you're working on at the moment? Basically, the cylinders that you sent me on LinkedIn, these images of these black cylinders, or is there like more to it that you're developing? Is there more around
Uh,
it?
Yeah, no. Initially, because my prototype design does it, initially on the patent that I have with the U.S. government, I have a diagram where it is an electric motor initially, just
Mhm.
because that's the, you know, I know that there's a lot of thrust production in like airplane like airliner engines which use turbofan technology. Um, the the issue being that it's really difficult to make a prototype that's cost effective
Yeah.
using huge like turbofan engines. So I even tried to get. I know there's model airplanes use like really simple ducted electric motors, which we're also looking at as for like small prototypes and whatnot. And I think again my collaborator Ashish in India is working on one of those prototypes in regards to electric motors with like a model airplane kind of ducted turbofan. But we decided that in order to kind of prove the concept more at a basic level, we because the basic purpose of the turbofan or the electric motor is to compress the air and so that it's in under a high pressure system. So
Mhm.
we took that step out of this next prototype because we just want to show um, that we can have a high pressure system and then release that gas in a stream for a short period of time, and then the thrust production will achieve motion. So that's our basic premise right now. So I thought that it would be more cost effective if we got rid of the electric motor for now, and then we use the compressed gas cylinder just to show the thrust production is feasible, and that at later prototype stages we're going to bring back in the electric motor, and that will be the way that we can pretty much simulate the compression of the gas again. So, and then we would like to have pressure sensors because now that we have the cylinder that I showed you on the image, we know how much pressure is in the system because we're gonna put a certain amount of psi, and there's a gauge on it that lets us show how much psi is in the cylinder. So we can do experiments at 1,000 psi, at 2,000, at 3,000, and then we can see how much thrust is produced at those levels of pressure within the cylinder. In the future, we would definitely want to know how much pressure we're producing in the system with the electric motor. So um, ideally, we want the maximum amount of pressure. I honestly don't know. I mean, if some of your engineers out there know what the maximum amount of pressure that can be produced by like a turbofan engine within an enclosed space, I'd love to know because eventually, I don't know if there's any equations out there, but maybe there is an equation that kind of relates the amount of pressure within a system compared to the rate of gas release through a nozzle system. So I'm sure there's a calculus equation that probably describes this, one of your mathematics friends on the podcast or listeners can help us with this. If there's an equation where you have so much psi within a certain volume, and then you release so much gas per time, and that it would relate to an equation for how much thrust could be produced theoretically. I would love to work on an equation like that. Then we could make models that would predict, like if we needed to make, I'm just going to throw out a number there. This is off the top of my head. If we needed to generate 100,000 pounds of thrust, and I have no idea what that is in metrics, I apologize, but we want to produce 100,000 pounds of thrust. How much PSI would we need within our container to produce that amount of thrust? So I would love if we had an equation like that, and maybe there's a way of calculating that. But as of right now, this is what, the variables that we're working on pretty much is maximizing the amount of pressure within the chamber, and then releasing that amount of pressure in a controlled way to produce thrust. But, we don't want it to be an explosion like in a rocket engine. We don't want all the pressure to be released in 2 seconds or something like that. We want the pressure to be released over a continuous amount of time, maybe I'm just guessing 10 to 15 seconds. And we want to see how much thrust can be produced, because we don't want a large escape of the gas all at one time. We want a gradual, but enough, like I said, to produce some thrust. So, and like I said, I'm not 100% sure in regards to in the future if this is going to be a continuous process or more like I don't know, say an episodic or like a capacitor kind of a system where you're building up the pressure to 10,000 psi, you're releasing it over 30 seconds, and then it might take you either an hour to recharge the system or whatnot. But it doesn't have to be, I know like with chemical rockets, you're trying to burn the fuel in a rapid way as fast as you can to produce the most thrust in the fastest amount of time to make, like your acceleration as high as possible. I'm not looking for high acceleration system. I'm looking more for, it's kind of like if you're running a marathon or you're sprinting. I'm not looking for a sprint. I'm looking for a marathon in regards to this. I want enough thrust to move my mechanism, but it's not going to be, this isn't like a race to get to Mars within, I don't know, within like 3 months or something like that. I'm looking for a system that is sustainable over time with electricity, and this might be more useful for things like probe craft. If one of my episodes I might have talked about probe craft. So, because we're looking for something that even if we get, let's say, 10 meters per second squared. I forget what the acceleration numbers might be for something. We don't want like a huge amount of acceleration. We're happy to have a little bit of acceleration over a long term, because we don't have to worry about refueling the system like with chemicals and whatnot. We're looking for if something that can, and I can see some implications for this that go beyond, propulsion. So if we could, I don't know if are familiar with the NASA's Voyager program, where they sent the Voyager probe out of the solar system. It'll go on for infinity, theoretically, going off into the depths of space. But if we could have like an internal atmospheric propulsion system, one of my dreams would be that we could send a probe, let's say, let's make it like in somebody's lifetime. So let's say like 50 years at continuous acceleration towards, I don't know, the planet or the star Vega or something. I know that's one of the big stars they use in science fiction. So we send our probe, and it's only accelerating gradually for 50 years towards the planet Vega. If we have a continuous acceleration, even if a little bit, over 50 years, that's going to come very close to hopefully, hopefully like half the speed of light. I don't know what the calculations are. Let's just say over 50 years, it'll get to 0.5 C. If the probe has enough like instrumentation on it and whatnot, we could do a lot of experiments on, what happens at half the speed of light and whatnot. But as compared to the Voyager spacecraft, where we just have to let it go out and it can never come back, if we had a way of recharging the electrical system, either with solar panels or another way, we could theoretically, after 50 years, stop it and then turn it around and bring it back. So that's ideally what I would hope for the propulsion system. It's something that is sustainable over decades, and it's something that we can retrieve over time, not like with other probe craft where you have to let it go out into space and then it's gone forever. You can't retrieve it anymore. But if it was a rechargeable system with electricity, and it was ruggedized enough where we could keep using the propulsion system for decades, like I propose, and then eventually turn it around and bring it back to Earth. I'd love to do like experimentation in regards to bringing back probe craft, because I know not a lot of probe craft are brought back. Even like the rovers on Mars and whatnot, they're meant to be left there and never come back. So, but just the theory and whatnot. But I think that if we could kind of realize the implications of internal atmospheric propulsion, then maybe we could make craft that can be sent out and then also brought back as well. So sorry, I kind of expounded there for a minute, Jousef.
No, that's completely fine. I love it that because you have all that theory and ideas all in your head. So I really, really love that, and I hope for the future we'll see your prototype or like actually being in production, actually being used in outer space. Coming back to that equation, I think there must be an equation to actually calculate the pressure and then the thrust correlation to some extent. There has to be an
Yeah,
equation.
no. If you want to talk about equations, I love to talk about equations. Like the ones that I just remember from like my basic physics classes and whatnot is like the ideal gas constant, pressure, volume, ideal gas or the gas constant, and temperature,
Temperature.
and the moles of gas. So
Mm.
that's a great question, because now that you brought up the universal gas equation, I think my lawyer that helped me with the patent, he mentioned, and I'm not sure about this, maybe you have an idea, the type of gas that we have within the system. If we use like a noble gas like argon or something like that, would that have implications in regards to the compressibility of argon versus like an oxygen nitrogen mixture, which we have in our atmosphere? I don't know what the implications of that are. Would we get a higher pressure with a noble gas? Would we have more laminar flow with a noble gas, things like that? Because it's an enclosed system, we don't have to use oxygen, nitrogen. We could use other gases, and if the actual type of gas that we use improves the efficiency of the system, I'm more than happy to consider that. But I don't know. I don't have enough expertise in regards to like types of gases other than what are used like in aerodynamics and whatnot, which we use for our normal atmospheric composition pretty much. So, but yeah,
Would
no, if any of the chemists out there, or I guess that would be more like I guess the mechanical engineers also specialize in laminar flow and fluid dynamics. Is that correct?
it really depends. You get introduced to it in your bachelor's, and then in your master's, you could probably specialize in
Okay.
turbulent flows and CFD and all these kind of things. But
Yeah.
what kind of gases have you used before, like in your prototype
No, I
phase?
haven't. The only gases I've used is our normal atmospheric gases. I haven't used any,
Got it.
but
Okay.
it was just an idea that came up when I was had a conversation with our lawyer, because the lawyer said, yeah, that's one of the variations you might use in your system, where the system could use a different type of gas within the enclosed space. And yeah, and I said I honestly don't know if I've ever read any articles or seen anything where like a different gas. I know we would probably want to, there's certain types of gases that are more dangerous, like, hydrogen tends to explode and whatnot. So, of course we want to be as safe as possible, but yeah, no, I don't even know if like a heavier gas would be, you would get more thrust because it is has a higher resistant to compression. I'm not really sure if the potential energy of a compressed gas is affected. I'm sure it is, but if I don't know if anyone's done experiments with compressed gases using like argon or another like noble gas, like I said. But if any of your podcast listeners know of any experiments like that, I'd be happy to talk to them about it, and and interview them on my podcast and whatnot. So, but there's so many variables, and it's you can tell I'm kind of excited about the whole thing. But I'm happy to talk about anyone in regards to any of these variables that can affect the prototype production.
There's so much that goes into this, and I never done these experiments myself with these gases, so I can't tell for sure what's working and whatnot. But definitely, if someone of the listeners has some idea, or maybe we could even do some experiments at some test facility, I'll be more than happy to get in touch with you. So if you are listening to this podcast and have an idea, feel free to reach out to us, and we're more than happy to discuss.
Yes,
In the early
please. Yep.
prototyping, in the early prototyping days, Dennis, how did you Alfred, how did you approach this, by the way? Like, I think you used a soda can and did the first prototypes with a soda can. How
Yes.
did that work out?
Well, that's a great story actually, because when I had this idea, it was I was in the military. This was I was like 20 years old. I'm in my late 40s now. I'll be 50 in a couple of years. So this was like 20, 30 years ago. I was in the military, and I had a thought, just like with all these systems, everything is being kind of just wasted, so to speak, into the atmosphere. Is there any like contained system? Um, and I was just talking about like what kind of airtight container is easily available and whatnot. So the easiest airtight container I knew of are just like the 2 liter bottles that you have soda pop in and whatnot. So um, you know it holds gas in because it's carbon dioxide in the liquid. It has to hold the gas in, so it's rated to have some pressure within it and whatnot. Um, and then the other thing is like, well, I might as well just see if it's even feasible. And then I went on Google. I found like the smallest electric motor that I could find, and then and you can, if you go to my website, I have a link to my YouTube videos in regards to this, um, and I just pretty much inserted the electric motor with a basic propeller within the 2 liter bottle, and then sealed it to make it airtight. And then I have an indoor pool at my house, so I was able to place it on the surface of the water, and then I just activated the motor to see if there would be some type of motion. So, and this is where the sail effect comes in again, and if there's going to be some type of an issue in regards to, I can't even know what the fluid dynamics might be within that small container, but there was some motion. I think my initial theory or hypothesis would be that okay, there would be maybe some cancellation of effect. The thrust production might be canceled out by the sail effect, and the whole mechanism wouldn't move. But as the video shows, the mechanism is moving for some reason, but I don't have enough data to prove one way or the other um, if that thrust production was enough to make it a usable system. But just the fact that it moved on its own power, I think it deserves a further exploration, further experimentation. Um, so yeah, no, my initial idea was that if I were to do the 2 liter bottle experiment and nothing were to happen, then I probably would have given up on the idea. But but circumstances being what it is, and, God willing that the mechanism did move, and it kind of sparked my interest into this needs to be further explored. I think it deserves my time and my effort to explore it further. And as you see, I'm very excited about it. I can be very energetic in my conversation about it. So yeah, I'm always happy to work with any of your listeners out there that, and even if you disagree, I've had some engineers say that theoretically it could be not sustainable. There could be some setbacks, some challenges to make the system work, and I'm happy to talk with any of the engineers out there that feel that there's a lot of things to overcome. But I think that even if there are a lot of things to overcome, I can't put this idea down until I've proven it to myself that it's not sustainable, pretty much. So I'm happy to talk with anyone out there that feels that either my idea is not feasible or it is feasible. And like I said, I'm just trying to work it out to a point where I have enough scientific evidence that either my prototype is feasible or it is not feasible. But like I said, if you go to I have my website is belenaerospace.com. I have a podcast called Jets in Space. I have, I think, an account on LinkedIn under internal atmospheric propulsion. I'm also have some Facebook pages on internal atmospheric propulsion as well. But I just want this to be something that maybe, and I'm really happy that I'm on the podcast because I think this is a great way to collaborate with other engineers out there and other, scientifically minded people that might have, and maybe you believe that it is possible as well. And if you do, great. I'd love to have the help and the support for making this more of a reality. But yeah, so the next stage of the prototype, like you said, Jousef, is the 3,000 psi canister. I have a company in India that's helping me develop that right now because um, Um, and then, like I said, I have a patent on file, so I'm happy to share that with anyone who wants to look at that patent application. But I'm really hoping that over the next several years we'll have a prototype that proves the concept, and then after we've proven that the thrust production excuse me, is possible with the 3000 psi canister, we would move back into the electric motor. So the electric motor would theoretically take the gas from the system, compress it back into the canister theoretically, and then the process could be repeated over and over again. Um, you know, um, ad infinitum, pretty much, as long as you had electricity. So
Let's see. What I would be interested in, Alfred, is this project all self-funded? Because
it is self-funded right now.
okay,
So yeah, no, I'm always happy to talk to anyone that's willing to fund me. You know, if there's anything that you have any investors out there that are willing to talk more. You know, one of the ways that I'm hoping to generate revenue for more elaborate, more expensive prototypes is the patent, pretty much. So if somebody wants a percentage of the patent, you know, I'm willing to give a percentage of the patent to somebody for funding to make larger and more robust prototypes and whatnot. So yeah, if there's any investors on your podcast that are looking into purchasing a portion of my patent, I'm more than happy to share that information with you. And then I have a legal firm. I think it's Dunlap, I believe, is the legal firm, and we can work out an arrangement in regards to assigning a percentage of the patent to the investor. Yep.
got it. How does it look in the competitive landscape? Like, there must be someone who already tried your
That
idea.
is that is an excellent question. So actually, and one of my podcast episodes has to do with the patent as well.
Okay.
But in 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 um in the United States, I don't know how it is in the Netherlands and in Europe. If you want to apply for a patent, you have to do a search first. Um, so my law firm was able to do that patent search, and there is no concept under U.S. patent law that I'm aware of that has any device like this on file with the U.S. government. So yeah, so we're like at the ground level here in regards to experimentation in this kind of field, so to speak. Um, uh, so my patent is where is it? It's in the stages of almost, and you know that I'm not a lawyer, but there are different types of patent. There's like a utility patent, and then there's a provisional patent. Right now, my patent is provisional, and it's waiting the approval of the U.S. government. But it is on file, and I have all that documentation. So it hasn't been rejected by the U.S. government yet. So
Hmm.
that gives me good hope that it is a usable patent and whatnot. So I think that if you have any further questions, I can refer you to our law firm that can kind of discuss the kind of ins and outs, the details of the patent law and whatnot. But yeah, in order to have a patent approved, you have to do a patent search and look for other inventions that may have had similar type of um, design, so to speak, prior to your patent being approved, and that was done by the law firm. And as far as I'm aware, there are no devices, inventions, mechanisms out there that are remotely similar to internal atmospheric propulsion, which puts my mind at ease, which is great. No one's This is kind of like new and this is like new area that no one's ever explored and whatnot. So I'm glad that I'm kind of like one of the first people to look into this as a way of propulsion. Yeah,
Yeah, that's it's maybe it's like twofold. On one side, you could say there was nobody so far who explored your idea, but on the other hand, there could have been someone who explored your idea, but maybe the patent was rejected, or like it didn't even work
that's
out, and
true.
they didn't follow the path of acquiring a patent.
That's true. Now I don't know. I didn't have to ask my lawyer. So if someone were to apply for a patent and it was rejected, I'm not sure if that would be included in the patent search. I would think it would be, but I'm not 100% sure.
Mm.
I will actually send an email to my lawyer today or tomorrow and ask them when they do the patent search, does it include patents that have been rejected or only patents that have
Mm.
been
That
approved?
would be
Because
interesting.
that's a great question. I never actually came to that to that question myself, but I'm kind of curious if there was a patent that was rejected, then maybe that would give us some idea in regards to what they tried in the past and what didn't work. Um, but like I said, from my kind of basic training in physics and whatnot, um, I don't see the biggest thing that I and some of the engineers have commented on this too that I've been in contact with is that that the either the thrust to weight would be too much for it to overcome, or the thrust production wouldn't be enough where it would be feasible for it to be a system. Now, I don't know. Like there, my big thing is that I'm not looking to move heavy loads. I think one of my podcasts is, like I'm not looking to accelerate a body through the Earth atmosphere and get it into orbit to achieve escape velocity. IAP is not going to do that. That's still going to be, like rocket powered things to accelerate things to escape velocity. I don't think IAP could do that. I came up with some weird ideas. Maybe you could do it if you had enough, you know, IAP modules in linear or in tandem, possibly. But I think for the next like 100 years or so, I think chemical rockets are going to be the mainstay for lifting bodies off the surface of the Earth. Now, when you're off the surface of the Earth and you don't have an you're in the vacuum of space, and you're traveling through like the vast reaches between like planetary bodies, then I think IAP might be a good option because, like I said, you don't have to worry about refueling depots. And then you have, and if you're not like if this is more like a supply chain kind of a propulsion system, you need to send supply ships back and forth between like the moon and the Earth, and you're not looking to use a lot of chemical engines, and maybe you can have like a slow moving kind of supply train moving back and forth between the Earth and the moon, and it's not dependent upon chemical reactions. You could just use electricity, solar, nuclear, whatnot. So I'm not, I'm trying to be as realistic as possible. I'm not looking for huge amounts of acceleration, moving huge amounts of, I'm not looking to move heavy loads, so to speak. We just want a little bit of propulsion, but over the long term, this is something that can be sustainable, like I said, with the probe craft as well. So, and maybe that's why it hasn't been too much of an emphasis in kind of like space experimentation, is because people, when they think of space, they're thinking more of like big chemical reactions where you're producing a lot of thrust with a chemical explosion, and you're throwing the gases out the back of the vehicle. Um, I don't think anyone's thought to, possibly use a small amount of thrust, but powered electrically. So, like again, I'm hoping this is something that will even just spark the interest of other engineers out there, and maybe there are a lot of flaws in my design, but I'm happy to work on it with other people that maybe they can help me improve the design even further. So yeah.
That sounds good. What I really love about you is that you have the determination and the grit. You're always energetic. Like when you talk about your project, what is the hope for you
Yeah.
in the future? Like what is the dream of yours, the goal, the end goal, if there's an end goal?
Yeah. I mean, I guess there could be an endpoint. Like I said, on my podcast, I might have, or on my website, I might have mentioned, like I've always been like a space enthusiast since I was a grade school, maybe like 4 or 5, and whatnot. So, if this is something that can, reduce the cost, I think that's the biggest issue in my mind. Like
Hmm.
Elon Musk is always one of my favorite kind of characters in the local kind of the media and whatnot, because he kind of reduced the cost of like rocketry over the past several years and whatnot. And I'm hoping that's what this is going to be as well. So if space travel can be reduced in cost, especially, like interplanetary type of travel, and then maybe this would be a way for not just astronauts that are in NASA and whatnot can get to the space, but maybe even I would, in my lifetime, I would like to go to the moon, and maybe if that's something, I'm getting close to 50, but I know my body may not be as young as it used to be, but maybe space travel for the general populace would be closer if we had like an IAP system that would, because it, for me, space has to be cost effective. I think Elon Musk has kind of shown that if it's not cost effective, then it's all sponsored by government programs. It's going to kind of go at a very slow pace and whatnot. But if it is something where, you know, more cost effective systems can be brought into play, possibly like IAP, then there's implications for investors might want to start mining the asteroids around Saturn or Jupiter, and then colonies on the moon, all that stuff. I'm sure a lot of other people have thought about that and whatnot. But hopefully, IAP would reduce the cost of space travel, would increase the interest in maybe like economic development of other planetary bodies, things like that. So yes, so if my kind of contribution kind of helps get us to that next level where we have colonies on the moon, we have colonies on Mars, we have economic enterprises that are getting materials out of asteroids and mining them, that would be my ultimate kind of goal, is that we've kind of moved the place of, I guess, humanity in regards to where it is like off the planet a little bit more. So I think some people call that the diaspora. We're spreading out into the other planets and not being kind of contained on the Earth only. Yeah.
Mm-hmm. I have one idea because you mentioned Elon now. Assuming Elon would maybe listen to the podcast, you would have like 1 or 2 minutes. Let's say you have 2 minutes to pitch him your idea. So if Elon listens to the podcast, I give you 2 minutes now. You have to pitch
All
your
right.
idea to Elon Musk. Let's go for it.
All right. So, Elon, my name's Alfred, and I have this great idea. It's called internal atmospheric propulsion. And the basic thing is, like your Tesla cars, this is going to be a purely electric system. We're going to get rid of chemical reactions. We're going to get rid of the need for fuel depots out in space. We are going to use electricity as the primary source for fuel for our spacecraft. I think that if we work together on this, we can get to Mars. I know that's one of your goals. You want to get to Mars. You want a colony on Mars. The main thing I think that we can do with IAP is logistics. Logistics meaning we need to get supplies to and from the Earth to the moon in a cost-effective manner. So we're not spending $100 million to move 100 pounds of food between Earth and Mars. If we could do that, let's say instead of $1 million to move that 100 pounds, I brought the cost down to $100,000. So I've saved you there $900,000 because of IAP. I think that if you give me a call, we can make this dream a reality. We can get to Mars sooner. We can have colonies on Mars sooner, and then we could have the humanity off the Earth, and and the diaspora would be a reality. So
I love the pitch. Awesome. I'll extract that clip, actually post it on Twitter and see if Elon maybe replies. Let's see. that would be sick.
that'd be awesome. No, so if I get a call from Elon, I'm going to thank you, Jousef. All right.
Definitely, yeah. Sounds cool. All right. Any closing remarks? Any last words from you before we wrap it up?
No, I just want to thank you, Jousef. I know that your time is very precious to you, and I'm very appreciative that you actually I know you're talking to me a couple hours earlier than we planned, so I know you've been very flexible with your time, and I see that you're very supportive of the idea. I really appreciate that as well. I just want to say thank you again, and I'll send you all my links and whatnot to LinkedIn, to Facebook, the website, and I think that we're also going to do. You're going to be my guest on my podcast, Jets in Space, and I know that AI is one of your kind of interests as well. So I think when I interview you on my podcast, I'm gonna talk about AI, like some of my favorite AI movies, like The Terminator and 2001: A Space Odyssey. We'll talk about that, and then I want to talk about maybe how AI might be used in IAP. So we'll do that. So I'd like to talk to you on my podcast about AI, movies with AI, and then implications of AI for IAP. All righty.
That sounds cool. All right. With that, we'll call it a day. Thank you so much. Really cool idea. I hope that you'll have a lot of success, but we'll definitely stay in touch, and I'll send you a few interesting contacts right after this podcast.
Oh, any contacts you can send, I'd be happy to. And then, yeah, so probably the easy, I'm going to give you like if my email, of course, and my cell phone. You're welcome to give my cell phone out to anyone who really wants to get in touch with me. That's probably the fastest way to get in touch with me is my cell phone. But I don't know with international if they would want to like text a U.S. number or not. But text messages are fine. But I usually respond to text messages a lot faster than I do emails because if I'm at work and whatnot, I may not see an email for like an hour or two. So if anyone wants to get in touch with me within minutes, probably text is better. If they can wait a couple hours, then email is fine.
Sounds good. All right. Thank you so much, and see you soon.
Thank you, Jousef. All right.